Hello everyone and welcome back. Today we are going to be doing the Firm2 challenge from the IoT category of the wormcon CTF. In the last video we went over the solution of the Firm1 challenge, and so I might skip on some of the details of this challenge. If you want, please first go and watch that video. So we are simply given the link to download the file and we have nothing else, and this point is worth 400 points. So now we can go over and start analyzing this file. So first let me copy it into my current directory. It is here, and this is the file. So we can begin as we did in the previous video by simply running the file command, and we have the same output as in the previous video. And so we do a simple dump image -o image and then the file name, and then we can run file against the command, and we get this is the same kernel version, and we can unpack it the same way as we did in the previous video. Now I am not going over how we knew how to do this because this was all covered in our last video. So if you have not watched it, please do so. So we can extract it all using binwalk, and then we can go into the directory it creates, and again we can look at what all it created, and we can also use the tree command. Now we see we have quite a lot of content, and all of these point to busybox, which is a multi-purpose binary. If you want, you should read up on that. And we have a backdoor directory which seems interesting in etc. It is, I don't think it's a directory, it's a file. We can check that. It is the only thing that stands out now. Let's see anything else. And we have a user bin backdoor. Now this also seems very interesting, especially since it's written in this lead language, which is very common in CTFs. So we have two things to note right now: the user bin and backdoor and /etc/backdoor. So now we know what seems interesting. We can go and check it out. So the first thing was the backdoor in etc. We can do file backdoor. It says it's a elf file, not strip. So we can do strings on this, view them using less. So we have socket, exit, fopen, perror. We are using libc, and we have this long hex string and send.txt. We can copy this, we can keep this hex string handy. And so let's try and reverse this binary. So I'm going to be using Ghidra, and let's just open this up. So we can open up a new project. And now we can import in the file. So we can keep this at default, and then we can open it up. Do you want to analyze it? Yes. And we can let Ghidra do its things, and we can then go to the main function. So we have this same hex value that we saw previously. We have a send.txt file and hex 50. So let's say it says error in socket, then it looks up inet addr. What it will do is look up the IP address of a domain. So I am thinking this is going to be characters. So we can try that. We can copy this and use this unhex utility, and that seems like garbage. So it is sending some file. So I just wanted to make sure that it is not doing anything very malicious, and now we can at least try and run that file. So I will simply copy the, let's say, take the hostname file as send.txt, which it's going to be using. We can copy the send.txt, and now we can execute this back, because it is not going to execute any commands on my system. So it says server socket created successfully and network is unreachable. So let's see what's the problem. We can do ltrace on this, and it uses inet addr on that, and it connects to it. Let's try strace. Let's see if we can see the domain somehow, because that hex was just like that. So there is nothing much interesting that we are able to do or see. We are only able to see that it is connecting to this domain, but we are not able to identify how exactly is it converting into characters. So what we can try to do is use GDB, do some dynamic analysis on this binary, and if we are still not able to find anything, we are going to use the binary in user bin. So we can do break main, run it, and then we can do disassemble main. So let's see, we can try to break at this call just before it calls inet addr, and so we can try to see what exactly is the domain. So let's see, let's uh, run this, continue, and let's see, that is still the hex string, and error in socket network is unreachable. Let me just make sure that this does not exist. Now hex 40 is, I don't think it should exist. It will be printable ASCII. So there is nothing in this binary. Now we can also try the other binary, not like that. I hit the I key, and it is in user bin backdoor, and now we can try this binary. Do you want to analyze it? Yes, analyze, okay, and I'm just waiting for it to do everything, and then we can view the main function. And the first thing I see is, let's try to differentiate between these two binaries. The other one open? I don't see the other one open. Now this is exactly the same as was in the previous binary. If you notice, it is exactly the same, except this local10 is no longer a hex. It is a call to this function, which I don't know what it's doing. We'll have to check that out, but except for that, everything is same. This is hex 50 send.txt. It is creating a socket. So socket created successfully, error in socket. This is exactly the same as that, except for that function call. So we can try to see what this function is doing, and again we have some hex, and it is calling this function with all these hex values. So we can check what this function is doing, and this is hex 50. It is taking the length of the parameter 1, which is going to be the string. So we can say len param1. This is again going to be, let's simply len, and this is using local c to iterate, so we can name it I. So while I is less than length, and we are using this local 38, let's name it a buff or a buffer plus I. Okay, so at that offset we have param1 XORed with local D. Now local D was simply hex 50, and so what we are doing is basically XORing every byte with hex 50. So we can go back to our previous function and we will have to copy all these bytes. So let's copy this, and I'm going to be doing this using Python because it's simpler to do it. So part1 is equal to bytes dot from hex, paste it in, and we need to get rid of the 0x. What is part1? Gibberish. And now we need to XOR it. So I am going to be using the XOR function from Pwn tools. You can install it simply using pip install Pwn tools, and now we can do XOR this part1 with hex 50 and we get this thing. So let's move forward. Let's copy this. Part2 is equal to same bytes from hex, paste it in, remove the 0x. Part2 is again gibberish, and then we again XOR part2 with hex 50 and we get this. Now let's take the other three parts. So we have all the parts that we need. Again, part 3 and part 4. Now if you look carefully, this is becoming one freak, which is the name of the organization which is actually hosting the CTF, but this is reversed. So if you look carefully, it is one freak ak.org. Now this is completely reversed, so we will need to reverse it. We can simply do it like that. That is part1. Part2 is like that, and now we can join all of these strings together and let's see what it forms. And we get this URL, so we can try to visit it, paste it in, visit it. Let me try from my host machine. I'm going to go back to my host's browser, see if I can visit it. New tab, paste this URL in, and there we have our flag, and we can now go ahead and submit it. It is on the same domain. So that was it for this challenge. I hope you liked it. If you did, please make sure to like the video, share this with anyone who might like this, and that's all. Thank you.